The top NASA exoplanet program. NASA's exoplanet program is an ongoing effort to find planets outside our solar system. NASA tracks over 200,000 stars using a HARPS spectrograph habitable zone atmospheric telescope. If you're considering traveling to the stars to find your life's purpose, we have some good news. One of these super-Earth planets could be our next home to date. We have discovered 24 known Earth-like planets in our Milky Way galaxy. Would they be inhabited? Please subscribe, like, and leave a comment below. After gathering sufficient data on a star using panchromatic satellites, researchers will compare it to other stars to determine whether they share the same chemical composition. Stars are categorized based on their brightness and temperature, ranging from white dwarfs to red giants, supergiants, hypergiants, and neutron stars. Scientists have discovered that if a planet orbits a star smaller than our Sun, it will be too close for liquid water to exist. Other stars are too big or too small for their planets to be habitable, but NASA is now considering stars that are just right giants. These stars are more than 10 million years old, have a surface temperature of up to 25,000 degrees Fahrenheit, and are too big to support life on a planet because they could be flung into space by gravity. They are also too big and bright to be surrounded by any potential planets. M-dwarf stars are stars that are smaller than. There are 3 types of stars that are likely habitable. The habitable zone is the range in which a planet can orbit its sun and have liquid water. It is not just a line or radius. It depends on a number of factors, including the type of star it is orbiting, the gravitational pull of the star, and other factors. Our Sun is roughly 0.5 to 8% the size of our Sun. If a planet revolves around one of these, it will likely need to be farther away from the star to avoid having its water boil away, though its star, the amount of solar radiation it receives, etc. K-dwarf stars are small stars. We know they are only 1.2 times as big as our Sun, but their surface temperatures can reach 6,900 degrees Fahrenheit. Earth-sized planets would likely have no trouble sustaining liquid water around these stars because their atmosphere doesn't receive intense ultraviolet radiation from their lead, and there is no danger of the tidal lock, where planets in orbit would encounter an extreme. We know that neutron stars are the small stars that are about 12 miles across. They typically have a solid magnetic field and an atmosphere of hydrogen and helium. Since these planets are so small, a tidal lock is not an issue. Neutron stars that are at least 3 Earth masses can be habitable because they are small, quiet, and have a stable orbit in their habitable zone. Red dwarf stars are the most prevalent type of stars in the galaxy. They are similar to our Sun. Red dwarf stars, which are the regular stars like our Sun, have a surface temperature between 5,200 and 6,700 degrees Fahrenheit. They are not as bright as other stars and haven't yet experienced the stellar wind or caused their planets to spiral into their Sun. If a planet orbits around one of these, it would be able to hold on to its water because they are in the habitable zone. Our galaxy contains red dwarfs, or suns, that humans could potentially settle. Number 4. Exoplanets. Extrasolar planets. Exoplanets are planets outside of our solar system that can orbit other stars and experience similar conditions to our solar system, such as heat, gravity, and light. They are between 1.5 and 10 billion years old, and a planet orbiting them would need to be outside the habitable zone to maintain liquid water because they are significantly hotter than smaller stars. These stars are thought to be stable long-term, stars that are essential to life. The Kepler telescope's ability to detect orbital movements over time has led scientists to focus on the search for exoplanets. These exoplanets can be located using a HARPS spectrograph, habitable zone atmospheric research, and panchromatic satellites. Previously, we believed that our galaxy was only home to stars that were countless miles away from us. However, researchers discovered that another galaxy lived next door because these exoplanets are closer than we previously believed. The nearest exoplanet to date is Proxima Centauri b, which is located approximately 4 light-years from Earth. It orbits a red dwarf star 4.2 light-years away from Earth. Scientists estimate that Proxima Centauri b is roughly 17% denser than Earth. It is comparable to the Moon because its rotation takes more than a day to complete one orbit around its SAR. The exoplanet is tidally locked to its star, meaning one side of the planet would experience constant light while the other would be in continuous darkness. The planet is 3 times larger and warmer because it is close to its star. This means it could have liquid water. The star it orbits is much smaller and dimmer than our Sun. 4 light-years from Earth, the exoplanet Gliese 606c orbits another, red dwarf star. It is roughly 2.5 times the size of Earth and is situated in the Goldilocks zone, a habitable zone where temperatures are ideal for liquid water and the possibility of life. Gliese has a triple star system, with 2 stars in close orbit of one another. Kepler 22b is an exoplanet that was found by NASA's Kepler telescope and is approximately 600 light-years from Earth. The Kepler telescope has found numerous types of planets in various sizes, densities, and orbits. These planets are considered habitable because they have the right temperature and environment to be habitable, but they are all unique in their own way, some of which defy all logic or our understanding of science. The planet is roughly 2.4 times the size of Earth and is about 210 degrees Fahrenheit warmer than it because of its proximity to the star it orbits. 01. This odd exoplanet is only the size of a giant asteroid, but it is denser than lead and orbits near its Sun, possibly making it one of the hottest exoplanets. One of the 3 exoplanets in the TRAPPIST-1 system, TRAPPIST-1, is about 40 light-years from Earth and is thought to be a possible new Earth because it is roughly 60% larger than our own. It is habitable due to its size and habitable zone. The strange exoplanet LHS 1140b is thought to be habitable because it may have liquid water on its surface similar to Earth. It orbits a red dwarf star about 12.5 light-years away from Earth, is about 14% smaller than Earth, and may be one of the smallest exoplanets in terms of mass, but still on the scale of possibility that it may be habitable Titan moon. It has similar mass to Earth, so it can also have an equal surface gravity. It is also relatively close to its star, making it calm and stable. Titan Saturn's largest moon, which is between 179 and minus 290 degrees Fahrenheit, has an atmosphere that is dense with nitrogen, methane, hydrogen, and other hydrocarbons, and organic molecules. Scientists believe that this exoplanet has a cycle of rainfall, rivers, and lakes. Gliese 581g is roughly 20% larger than Earth and has a surface temperature of 290 degrees Fahrenheit on the side of the planet facing its star. Over the past 10 years, scientists have discovered that moons around planets can also be habitable. Tatooine, a planet near the outer edge of our solar system, is about 2/3 the size of Earth and orbits a star that is relatively close to our Sun but much smaller. The star is orbiting an elusive dwarf star that makes it more difficult for scientists to find it because it passes through the star's habitable zone every 2 years. Because of this, the temperature on the side of the planet facing away from its Sun can reach 40 degrees Celsius. Number 7. Dragonfly Mission. A lightweight telescope that would orbit Venus and scan the sky like Kepler did, the Dragonfly is an idea for a future satellite project to search for exoplanets that resemble Earth. It would be able to detect exoplanets, even closer to our stars, and find planets with water, which would be a good indicator of life. Number 8. Exoplanet Catalogs. Since the early 1990s, astronomers have cataloged thousands of exoplanets, and over 1,600 exoplanets are known to exist, 464 of which have been confirmed, and the Kepler telescope alone has discovered approximately 13 million potential exoplanets. A study conducted by Joshua E. Schlatter an associate professor of environmental studies at Washington State University College, was used to estimate the number of exoplanets in our galaxy, which could reach 50 billion planets orbiting other stars like our Sun. There are 9 methods used to identify exoplanets. As more exoplanets are found, it's becoming clearer that our solar system is just one of many in our galaxy. With space-based telescopes, astronomers can now detect new exoplanets using a variety of different techniques. The radial velocity method of discovery depends on observing the star in motion around our solar system. Since the Earth orbits the Sun, the stars are scorching and all in action, so you can use this method to determine a planet's composition. When a planet passes in front of a star, the light from the star dims slightly. This information is used to find other planets by measuring the slight wobble of a star to detect the presence of an orbiting planet. If a planet orbits a star being observed, it can be detected by measuring the wobble caused by its gravitational pull on the star. The transit method can be used to determine the diameter of an orbiting planet by observing how much light it blocks as it passes in front of the star. Infrared light has assisted in making observations using the Kepler telescope, allows scientists to directly image an exoplanet when it passes between Earth and its star. The pulsar timing array is another method of finding exoplanets. For years, astronomers have attempted to image an exoplanet without success. They use a scatterometer that measures the light reflected off the planet. Being impacted by the planets, this technique has already found 2 massive planets that circle their parent stars about 40 light-years away. Spectroscopy. When light is passed through a device, the colors of the light can be identified using a spectrograph, which allows scientists to determine what kind of molecule is in space. They use spectroscopy to search for particular signatures in the light emanating from the planet, which inform them of the composition of an exoplanet. Regarding its oceans, atmosphere, and life-supporting potential number 10. Priority research scientists now know that Earth-like planets can be found, orbiting low-mass stars because they are only a few million kilometers away from their parent star. The geophysical activity on these planets may be far more intense than on Earth, and it is still unclear how this would affect human bodies and adaptability. This is the primary focus of research number 11. When a planetary body, such as a moon, or planet, rotates so that one side of it always faces the planet, a process known as tidally locking occurs. This can lead to 2 things. Tidal bulges form on the tidally locked side, while the other side becomes flattened or burned. Scientists say that this would be the biggest threat to life on an exoplanet because many organisms can only survive. In extreme environments, number 12. Future research will look at whether life could adapt to the high levels of energy and light in a tidally locked system, number 13. Current theory suggests that large terrestrial planets are not tidal locked. Recent estimates indicate that stars smaller than 0.6 solar masses will initiate the process of tidal locking because they wouldn't have enough gravity to keep a planet in its orbit once it reaches the runaway greenhouse state. Scientists believe that because some planets, like Pluto, have tilted rotating axes, similar to nearby solar-type stars with different processes, the tilt could have catastrophic effects on the planet. For one thing, the nights and days will be longer and colder, which could negatively affect the climate and cause droughts, tornadoes, and hurricanes. For another reason, sunlight would reach parts of the planet that aren't facing the sun during specific periods, number 14. A planet's habitability can be assessed by measuring its orbital size and looking at the star's habitable zone, which is the region surrounding the parent star where liquid water may exist on a planet's surface. Many exoplanets that have been found have features that could support the possibility of life, but one factor is the distance from its parent star, which could make it too hot or too cold to support life. Therefore, habitability size is one of the most important factors in the size of a planet determines its capacity to support life. A planet needs roughly 1.5 times its radius to have liquid water on its surface, If a planet is too small, it will be too hot or dry, making liquid. Water impossible. Water must have enough gravity to hold on to the atmosphere and the proper amount of atmospheric pressure to prevent it from evaporating into space. For a planet to have a stable existence and decrease the likelihood of being struck by asteroids or other bodies that could cause in order to protect itself from the harmful radiation emitted by its parent star number 15, the planet must also have a sufficient amount of gas in its atmosphere. In order to understand other planets and how they were able to produce features like mountains or oceans, scientists are interested in learning how Earth formed. They have already found a few hundred exoplanets, but they still don't know much about them. Many of them are gas giants and other features like mountains and oceans, as well as the moon and a magnetic field, don't seem habitable, which raises the question of how many other low-mass planets could support life. A number of missions and projects are currently underway to help understand the composition of exoplanets, their formation, and the potential for life. With the help of new technologies, scientists will be able to observe exoplanets more closely than ever before and ascertain whether or not they have atmospheres similar to Earth. Follow and subscribe to stay informed about the future of the galaxy.